moss, plume, polyhedroid, crazy lace iris, the styles and colors to be found among agates is seemingly endless. Some are named like those based on their looks. Others are location-specific, like Fairburn and Lake Superior. In this latter group of regional agates are a collection dominated by subtle earth tones with occasional pops of color. These are the Columbia Basin Agates. In the rain shadow of the Cascades, some areas in eastern Washington between the mountains and the Palouse get less than 5 inches of rain annually. This means it looks like this much of the year. Well, away from the rivers anyway, because the rivers are the lifeblood of this desert. The Yakima brings in rainfall and snowpack melt from the Cascades, the Columbia meanders down from northeast Washington, and the Snake River gathers water from northern Idaho. Like all rivers, their paths have changed quite a bit over the millennia. Geologic forces have shoved them around or trapped them in incised valleys, and the flood basalts repeatedly filled in their channels and forced them to cut new paths time and time again. Evidence for abandoned river channels crop out in many places, and these ancient riverbeds are the local source of Columbia Basin agates.
There's a few different methods to understand how rivers have changed or where they've been over time. And a lot of the methods that were worked on in this area is using aquatic biota like microtine rodents and also things like fish that are fossilized within the units. Other methods that we've been working on and that I've started to apply in this area, one is called detrital zircon provenance analysis. Where we are here in the Columbia Basin, this is an area of accumulation. It's a basin where many rivers come into the region. And so really the story we're looking at is not one river versus another river being in an area. What we're trying to understand is which rivers together may have been contributing into an area.
Agate, like jasper and flint, is a subgroup of chalcedony, a cryptocrystalline or microcrystalline form of silica. It's microcrystalline if microscopic analysis shows crystals, and cryptocrystalline if not. Agate isn't a true mineral and is instead a mineraloid, meaning it's made of a mineral, in this case quartz, but the quartz isn't arranged in any particular unit cell structure. It's the same story with opal and pearl and obsidian. But just because there isn't a structural pattern doesn't mean everything's smashed into the agate willy-nilly. The teensy-weensy quartz crystals, aka crystallites, are arranged in parallel to subparallel columns. One way to think of this is to look at a Herkimer diamond. These are actually quartz, and the ideal form is a doubly terminated quartz crystal. Now take that crystal and shrink it down to micrometer size, and you have a crystallite of quartz, more or less. They can be arranged in one of two ways in agate. One is stacked on their side, like this, and that's called length-fast chalcedony. The other way is end-to-end, and that's length-slow. Most chalcedony is the length-fast variety. Both length-fast and length-slow chalcedony form essentially fibers that often grow radially, forming the botryoidal, rounded, and stalactite-like habits of many agates. The iris effect of iris agates exhibit this fibrous effect tremendously, and it also shows that these fibers in agates grow perpendicular to banding, which is why you have to cut them in a specific way. But what about Columbia Basin agates? What do they look like? Let's dive right in.
Every type you can think of. I mean, all the way to personally having found an anhydrous one that's very showy and large. I think it's 10 or 11 ounces. It never ceases to amaze me.
I've been here, this is my third time looking for CBAs in this place, and third time so far getting skunked, but it's just such a gorgeous place. It's not a problem to be out here and not finding that, because I'm finding lots of other good stuff. I think that my eye for Montana agates is actually interfering with my ability to find CBAs, because I tend to look for the shape and the texture and the geometry. When I see that in these rocks, I'm like, oh, that looks like an agate. Of course, there's a big thing of basalt. Or it'll be a metamorphic rock with striations, right? And I'm like, oh, look, petrified wood, which of course it's not. And so that has been kind of difficult. The other difficult thing is that even though I've watched all these videos of YouTube, and I've like every video on YouTube that has Columbia Basin agates, I've never actually gotten my hands on one. And they seem to be all different kind of tones and shapes and colors, and it's like, what am I looking for? I don't know.
In terms of the display and the composition, everything. I've even found seam, and most people don't look for that, but I've found CBAs in seam agate form. I haven't cut and found an iris yet, so I haven't seen one of those yet. I would be willing to bet my pinky toe that they have to be in there. It's just a question of the number of bands. And there's such a variety of displays within the CBAs that I am certain they exist. I just haven't seen one of those. I'll show you some really complex ones you don't see very often within the CBA library. Extremely intricate fortification, orbiculars. Here's a beautiful saginite. It occurs when you have this crystal formation inside of the host rock in the VUG in space. And this formation occurs first, and along with many other crystals that could be present before the chalcedony is deposited in that same hole. And we presume that it was at least vapor or liquid or viscous state in order to encase this other crystal formation that occurred prior to it in the agate. It just molds all the way around it. And then in this circumstance, that got broken away and formed into one stone during the flood events. My largest CBA, just over 2 pounds, big old mosaic waterline banding in these stones is very striking.
The agates didn't form in the rivers or in the riverbeds after the fact, but where did they form? Like most agates, Columbia Basin agates formed from mineral-rich hot water filtering through a host rock, the matrix. What is the matrix? Basalt, for the most part. Talk about basalt in eastern Washington, and naturally everyone first thinks of the flood basalts, but their only contribution to the story was pushing the rivers around. The agates we find formed in different basalt, generally filling void spaces created by gas bubbles, amygdules they're called.
I have found lots and lots that still have portions of the actual matrix on them. And then there's also sometimes people might get confused when we talk about this with delineating that from a CBA that's packed into the flood deposit material. Some people might not know the difference, but if it's a piece of hard material from the floods that's all packed together like a rock, and it can be just like a rock, and there could be a CBA stuck in there, that's different than what we're talking about. We're talking about the actual agate with the host stone, but this one is a great example of a water line with a single red band in it, which is very, very interesting. I have agates from my claim in southern Idaho that are white water lines that have single red bands in them. I have several examples in my case.
Agates were slowly eroded out and rounded during transport downstream, just like the other pebbles and cobbles we sift through. The nature of the other cobbles actually tell us something about where the agates may have originated, because you see the agate-bearing conglomerate is chock full of yellow quartzite cobbles.
It's not just any quartzite, specifically these golden quartzites that have that beautiful golden staining on them might be derived from the Columbia River, and that is our current thinking. It's something that also some of my colleagues like Jim O'Connor in the USGS and Charlie Cannon are investigating by pairing our detrital zircon samples with also informative class counts of are there quartzites, are they golden specifically, and what other sort of companion cobbles might be in specific deposits. So that is our current thinking, but we're also looking into it in a little bit more detail now, because as you said, quartzites are not just sourced in the Columbia River. You find them in a lot of different places, but those nice golden ones have been, for me at least in the field, often an indicator that the Columbia River is somehow involved in deposition.
Golden potatoes, as Nick Sentner called them, the iron-rich waters and sediment stained these quartzite yellowish, and also gave the CBAs a similar look.
This is a classic CBA, what people would think of as a Columbia Basin proper, Columbia Basin agate. Now, one thing I will say is I have the advantage of having collected in a greater area than most people, and I can tell the origin if I didn't remember based on the color scheme almost for sure. The ones from outside of the actual Columbia Basin, they transition from yellows and reds and oranges into creams and browns and whites. Something about the composition of the soil. They're still stained, but the staining is different. And I can show you 2 quick extreme examples, but this is an extreme example of the difference in the staining. This is a Tri-Cities proper CBA. And this is an agate, presumably from the same source, but deposited about 100 miles away in different soil.
CBAs are found in ancient Columbia riverbed deposits. They're found elsewhere too, and we'll get into that, but the most famous location for CBAs is what's known as the Fur Road locality north of Pasco. Tens of meters of conglomerates crop out along the banks of the Columbia, and they're chock full of these golden potatoes. Or at least that was the story I told myself. During my walkabout with Kate, she noticed a large patch of dark rocks that I waved away as fill that was brought in to shore up the lowland area we were walking through. But those rocks stuck with me. Deep red rocks that I might have seen before, and that could indicate the story was more complicated than I thought.
These really dark brick red clasts that are perhaps derived from the Seven Devils Mountains. It's sort of in between where the Hells Canyon is and where the Salmon River Canyon is, but that's an indicator perhaps of the Salmon River system.
I revisited Fur Road with fresh eyes. The stained quartzites were still everywhere, but I was more aware of layers with darker rocks, especially what might be those dark red rhyolites from Seven Devils. While samples from Fur Road are yet to be analyzed, Dr. Staisch examined zircons from a similar stratigraphic depth upstream. The results suggested the Salmon Clearwater River was contributing material to the area around the same time these conglomerates were being deposited, basically like this figure but with the Salmon Clearwater further north. On the map, this conglomerate is PLMCG, a continental conglomerate of Pliocene to Miocene age, part of the Ringold Formation. These units are between 9 and 3 million years old, but people don't come here for the thrilling debate of Pliocene versus Miocene ages. Instead, this almost 2-mile stretch of public property, plus some discontinuous beaches downstream, affords the perfect opportunity for loads of rockhounds to come try their hand at finding a Columbia Basin agate.
It's an adventure, right? Because when I do finally find one, it's going to be a big deal.
This is an incredible water line, and then what we would call a floater or some chalcedony then deposited on top of the quartz crystals. But this one, what makes it so incredible is the way that it finished. I don't know that a person could have shaped it any better if they tried. And there's basically no damage. This was found at Fur Road.
It's easy to look at the abandoned river channels and forget just how much energy is required to transport all those cobbles. The Columbia River today is a relatively calm, controlled waterway due to damming. While still an impressive sight, the river used to be much more treacherous, filled with rapids and boulders that made navigation difficult. It once might have been even more so. Before about 5.5 million years ago, the riverbed was dominated by pebble and cobble clasts. Something changed at 5.5 and it became sand-dominated. It's probably a cascade-related change as uplift over that way and increased deposition in the Columbia downstream lowered the gradient and slowed the river's flow. Although that might seem irrelevant here, it means fewer larger stones made it down the Columbia into the basin, and since the agates had to travel quite a ways, it means fewer likely made the journey after the shift. To me, that means the agates found in the river today weren't brought in the last few decades, but are instead only eroding out of those ancient riverbed deposits.
The cobbles that are deposited down at the base of the Ringold Formation, the old ones that are maybe, let's say, 8 million years old, those were deposited by an energetic river system that was able to move those cobbles from their initial source area. And you don't get so many finds because they were washed further downstream. The river was energetic. Where we are here is where things got a lot more quiet, and it's a lake system, so it's very not so energetic. But the Columbia River right now, where it is, if you take out the dams and restore it to what it was prior to the dams, it would be moving similarly sized cobbles and coarse sand and material. And then within a river system, there's definitely different energies. And so there are also sand deposition in certain slightly quieter areas, like in an eddy, for example. But like the thalweg of a river has the capacity to transport bigger cobbles, depending on sort of the depth and how much water is moving through and how fast.
Why do they wind up here, though? I've used the term Columbia Basin a few times, and that's because the area is a relative lowland bounded by the Yakima Fold and Thrust Belt to the west, the Okanagan Highlands to the north, the Southern Cascade Range, and the Idaho Rockies to the east. What I find fascinating, though, is that the region has been a persistent basin for tens of millions of years, and it didn't have to be this way. The basin was flooded time after time after time by Columbia River flood basalts. The basalts frequently traveled down ancestral salmon and Snake River channels and spilled out into the basin, repeatedly filling it. And yet, the basin kept sinking, accommodating more and more basalt, so much so that the basalt under the Columbia Basin is nearly 3 miles thick in some areas. Just think about that. Hundreds of square miles of basalt, 3 miles thick, and the area is still a lowland. Water loves a low spot, and so the rivers kept returning, slowly finding their way back to the Tri-Cities, and with the rivers came rocks.
The earlier Eocene and Oligocene strata that underlies the basalt is thicker here in the Columbia Basin than in other places. So this has been a depot center for tens of millions of years. The Columbia Basin has several different geologic units, but the one I'm sitting next to is called the Ringold Formation. And here we are along the White Bluffs, which is an excellent section to view the stratigraphy of the Ringold Formation. And this is not sand, it's not cobbles, it's not actually a river deposit. What we're sitting next to is a lacustrine deposit, it's a lake. And so right now we have the river cutting through the White Bluffs section, and that's what's happening now. But at a certain time in the past, when this material was being deposited between about 9.5 and 3.4 or perhaps 3 million years ago, there wasn't a dynamic river cutting through the landscape. There was the accumulation of lake strata, and that was because of some blockage downstream from where we are now, which is an active area of research. We're still sort of trying to figure out why the lake was here and why it persisted for so long, and then also why it stopped being here as well. I think some places like where the agates are being input wouldn't necessarily have ceased depositing in this region. Those agates would just be deposited in a different portion of the landscape. And so where a river comes in to a lake basin is where a lot of the larger clasts like cobbles or even coarse sand are deposited in like a deltaic environment. It could be that those cobbles were still being deposited in the lake wherever those rivers were sort of feeding into it. And we see that in a couple different places, like in Clarkston, Washington, there's this beautiful pile of gravel, and the cobbles are enormous. And so that's also an area where the Hells Canyon is just upstream a little bit, and where the rivers probably had quite a bit of power prior to entering the basin. And then when they enter the basin, they lose sort of a lot of that speed and the capacity to carry those big cobbles, and they sort of just drop them out in certain locations. So I think the rivers contributing to the area would still be bringing those agates into the basin, but it wouldn't just be here where we now have in the Miocene a lake system establishing.
Agates from the Columbia Basin have been recognized for decades, appearing, for example, in the 1960 Catalog of Washington Minerals put forth by the state's Department of Natural Resources. In it, they describe agates found in conglomerates near Sunnyside and in iron-stained cliffs in Benton County. That sounds familiar. Despite their well-known presence, there's really nothing in the literature on these things. And before about a decade ago, the term Columbia Basin agate didn't exist. Popularization of the term is specifically from the Columbia River Basin Agate Facebook group formed in 2012, and the catchy term benefited from the growing popularity of unique regional agates like those from Lake Superior. Because they are only now catching on in the mainstream thanks to Facebook groups and their coverage in rock hounding magazines and YouTube videos, there remains much to be explored. Agates are, in fact, found elsewhere in the basin other than the main conglomerate beds along the Columbia. For example, the Horsehaven Hills and Anticlinal Ridge south of the Tri-Cities are a well-known source. Scattered agates in the hills would seem to suggest a Yakima River source, or at least a more local origin. But those agates I mentioned near Sunnyside, practically on the banks of the Yakima River, are actually ancient Columbia River deposits.
Currently, the Columbia River cuts through the Wallula Gap. We are not so sure that has been the consistent course over time. So as you alluded to, the Columbia River downstream of here may have entered the Columbia River Gorge further downstream from where it currently does. And the evidence for that is that we do find cobbles along the Horsehaven Hills, which is a structural high, near, sort of edging towards Satis Pass. We find those golden quartz sites also around Satis Pass and then downstream. Another piece of evidence is that there is some basalts that are in the upper portion of what is now the Columbia River Gorge. That were deposited about 5.4 million years ago, and we find them on either side of the river corridor, suggesting that the major river was not incising into that area at that time, and that it would have connected downstream. It would have been incising downstream, but not of that particular area, and so that's called the basalt of Tethero Butte. And again, another active area of research. Why it shifted is still something that we're trying to figure out. One of the things that we're thinking about could possibly be the course is that if the Columbia River was following the Horseheaven Hills and over Satis Pass or somewhere around there, about earlier than 5 million years, then it had to change. And one of the reasons why we think it may have changed is that it may have been subject to some basalt infiltration from the what are they called? I was just talking about them earlier today. The Simcoe volcanics, exactly, which are erupting around that time period. And if they were to impede the river in that particular corridor, then that could possibly give rise to a lake system upstream. And if that lake system continued to infill the basin, it might eventually find a different way through, like Wallula Gap. But we're still working on all of the samples, so we've found the evidence for the river being there, but we still don't know exactly what time the river was there and exactly what the zircon makeup is of those particular samples. So they're in the lab.
These areas that seem timeless are really very much in motion even today. CBAs are also found scattered across many farmers' fields throughout the basin in what are likely glacial deposits.
I will hunt for agates that were deposited by and or moved around by those ice age flood events. And for me, I'm kind of grouping those agates into one category. One could say that if you were hunting CBAs in a true sense, you would have to be in the Columbia Basin. And I don't necessarily disagree with that, but I do hunt for agates that were moved around and deposited by those same ice age events and even others that are in deposits the exact same way as they are in the Columbia Basin within 100 miles or so of that location. So true CBAs, one might say you have to be in the Columbia Basin, and it's really anywhere. There's a large area in that bowl and even beyond westward because of the movement of the floods. But I also hunt upstream of the Tri-Cities. On the Snake River, there are patches of gravel, few and far between. And then there's deposits in the Lewiston-Clarkston Valley as well that may or may not have been from the exact same floods as that gravel that is in the Tri-Cities, some of which undoubtedly probably was. It's not that far.
There are a number of proponents of the theory that the Columbia Basin agates were in fact brought to the area by the Missoula floods. During the last period of continental glaciation, there was this whole thing with ice dams causing pooling meltwater that periodically released as massive floods. The floods reshaped the surface of much of eastern Washington, scouring topsoil from many areas, carving cliffs, changing the course of rivers, and we often think of this as an erosional story, but there was also deposition. The water had to go somewhere, and at times it was backed up in the lowland of the Columbia Basin as all that water came up against the Yakima Fold and Thrust Belt. You know, the same one that pushed around the Columbia River. Well, by this time the Columbia had established a water gap through the Horseheaven Hills at Wallula Gap, and this was the only significant water gap in the Columbia Basin. So all that floodwater backed up and had to wait patiently for its turn as glacial Lake Lewis before continuing its journey to the Pacific. And remember, this water had traveled something like 250 miles, picking up millions of tons of debris on its chaotic journey southwest. Suddenly finding itself in a lower energy environment, a whole hell of a lot of debris and sediment, everything from mammoths to little grains of silt, fell out. At the margins of these backwaters, which were over 800 feet deep in some places, the finer sediment formed dozens of layers of the Pleistocene deposits known as tushy beds. All this to say that it shouldn't come as a surprise to find Columbia Basin agates in these floodwater deposits. The same energy that dug out Frenchman Coulee and Dry Falls would have easily gouged the loosely cemented Ringold Formation and redistributed those agates. Despite the flood's power and amount of material transported to the basin, I don't think the Missoula floods are the source of CBAs. For one, we find CBAs in the older Ringold Formation deposits, which are over 3 million years old. The floods were only in the last 20,000 years or so, and while some evidence suggests these floods may have happened significantly earlier, like hundreds of thousands of years, it's still not the millions of years needed to bring material to the basin in the Ringold. In addition, there aren't really much for agates around Spokane either, especially none like the CBAs.
You can almost draw a line on a map and the agates stop. And I don't mean a little bit, I mean completely. You just don't find them. People will say sometimes that they find agates up towards Spokane and all the way, but they don't. They don't. I've never seen one. I've hunted a lot myself. I've talked to other people who I trust would know, and they say the exact same thing. A lot of people are mistaken. They'll find quartzite and other things that are similar, which is common depending on your level of experience. I've never seen one, not a single one validated. And the line is somewhere around Connell and anything north, and it's a little bit diagonal. It moves towards the White Bluffs, and then there's a little bit of splash, and you can never say never, right? Maybe there was a huge splash event that put some agates in one spot but I'm telling you, I haven't seen a single one north.
There are plenty of old river channels and gravel bars in northeast Washington, so it stands to reason that we should find at least some of the same agates up there as down in the basin, if that's where they come from. But maybe the CBAs are from farther afield, like Montana, the source of the floods. Except by and large, Montana agates just look different.
Montana agates look a lot like potatoes. They have the little dimples that the potatoes have, and they also have kind of that potato-y skin. It's almost like an elephant hide. And so the shape and the texture will both give you clues that it's an agate. It's also a really translucent stone, so when the sun shines on it, it actually glows, depending on how dirty it is. The rocks are really dirty this year, so not much glowing going on. But and so in that way, it's once you learn what you're looking for, it's pretty easy to spot because it's a glowing rock on the beach. So I was like, oh, look at that. It's a glowing rock on the beach. And these, like the CBAs that I've seen, don't seem to have that quality. They don't seem to have that, that translucence. And so I've been looking for waxy stuff. I've been looking for stuff that looks kind of agate-y. I found lots of what you said was called golden potatoes from Nick Zentner. They're cool. They're like a river stained quartzite that's really pretty, except for I guess it's not really pretty. It's just river staining. And so, I keep picking stuff up and thinking maybe this is it. And it just hasn't been. It hasn't been. And I can look around on this beach right here, and I can look at several rocks that would, if we were in Montana, I would check to see if they were agates. And obviously, I'm just not looking in the right place. But that's okay. This is the right place, and I'm having a good time.
There's a lot of plausible theories, but if you follow the actual gravel all the way to the source of the Missoula floods, there is a hard line. It isn't like a slow petering out even. It's a pretty hard line, and there's just nothing above that, which I always found to be interesting considering how many agates there are that come from Montana, right? But I think it was those events sourced north of all of that material, like the Yellowstone River material. I think that's out of the Missoula flood path. And I think the Missoula flood path was north, if I'm not mistaken. So yeah, and so that makes sense there. That was one of the first things I learned was I thought they all came from Montana, where all the Montana agates are. And quickly I learned that wasn't the case.
To me, the presence of the Columbia Basin agates in the younger flood deposits just means they're reworked, a geologic term for being eroded and redeposited. However, it's kind of like proving a negative. We can't say for sure that no agates were brought in by the Missoula floods, but I'd say the majority of what we call CBAs come from elsewhere.
Imagine how things changed over that period of time in terms of what was being moved. After the first few dozen floods, there was different material in the pathway of those floods, right? All the original material was probably blown out by then. Things like that happened in theory. And so you can get pretty far down the rabbit hole, but as far as knowing that I'm hunting ice age flood events, yes, I do know that. There's some pretty good maps, at least with some degree of certainty, I know that, right? And there are also other flood events that were known to have moved north on the map, if I'm not mistaken, called the Bonneville floods, Bonneville Lake floods. And I can't get too much more into it in terms of detail, or I'm talking over my head, because like you said, I'm not classically trained. But as I understand it, similar type events moving huge amounts of agates and other debris from the southern parts of Idaho and Oregon, and those places that have massive agate fields up above drainages that would slowly feed over time if it weren't for these big Ice Age flood events, right? These floods moved them all at once and left huge deposits in Lewiston-Clarkston Valley and in all the way to the ocean, right? From wherever the origin of those floods started, any sloshing or pockets would get filled in with gravel. In the case of the Columbia Basin, there were huge sloshing events. Some say even from the ocean there was back sloshing. I mean, we can only stipulate, but we know that gravel was deposited, and sometimes it's 100 or more feet deep. So huge, huge amounts of gravel. And what if, who's to say some of those events didn't put material in the pathway just prior to, or maybe a long time before, the Missoula flood started? So, in theory, debris could have been left in the field of those floods, and maybe the first third of the Missoula flood events were moving material that was already kind of laid in there, or an ancient river system was in there. By the end of the Missoula flood events, all that material has been deposited already. So you're not going to see it in certain parts of these deposits or across certain lines. And that's what we find when you hunt them.
Where are CBAs found today? Well, as mentioned, they're generally limited to south of Connell and the Saddle Mountains area. To the east, Jason has found them at least as far as the Lewiston Basin, and many people have reported finds downstream of both those places all the way to Goldendale, as well as further from the river in places like Sades Pass. This is all technically within the Columbia Basin as defined by the Washington State Department of Natural Resources. So, like it or not, they are indeed all Columbia Basin agates.
The agates stay in deposits that sort of flow along that snake, and the Snake River Plain itself was blown out many, many times by huge floods after these Ice Age flood events, because it was a natural river system, and that was over 10,000 years ago. So imagine the number of large flood events that occurred within this new river channel that was formed after the Ice Age floods. All that debris has been pretty much flushed out too. So when we talk about hunting gravel on the snake, we're not hunting gravel on the snake. You're looking for these itty bitty teeny tiny pockets up out of the channel. They can't be in the channel because of all the flooding that occurred after the Ice Age deposits. All that material, like I said, has been moved. You won't find hardly any CBAs. You won't, I mean, I'm sure there's an exception, but I've hunted all these places extensively, so I'm pretty confident in my ability to spot the material, and with what I find after spending a huge amount of time. There's always an exception, but for all practical purposes, you don't find CBAs in the river channel outside of the Tri-Cities where the bowl kind of flattened out and everything's settled, because it's very narrow. So you have to get out of the actual canyon and find pockets in the farmland. And that's very hard to do. Most of it's covered. So
When I first started thinking about Columbia Basin agates, it was a Columbia River story. The agates were at Fur Road, after all, a Columbia River deposit, and I was ready to chalk up scattered findings elsewhere to the Missoula floods. But as we've seen, the story is more complicated, and I'm now leaning toward the ancestral salmon Clearwater River being the main source.
Where the Salmon River and the Snake River meet is just downstream of the Hell's Canyon. And so prior to the incision of Hell's Canyon and the connection between the upper Snake River and the eastern Snake River Plain through the western Snake River Plain, I still do think that the Salmon River was involved in deposition into the Columbia Basin, but it and the Clearwater sort of meet up near Lewiston and Clarkston, Idaho, and that's actually one of the active areas that we're trying to figure out where this Clearwater comes in and when. I think it has been consistently depositing throughout the Ringold history, because a lot of the cobbles that we find, like in the Snipes Mountain conglomerate near Granger, Washington, and also along certain portions of the White Bluffs where the fluvial gravels are at the base, we find a mixture between not just the Snake River Provenance zircons, but also the Clearwater zircon and Salmon River zircon provenance. So I think it was possibly still involved in deposition in this area throughout the history of this lake system too. The confluence would have still just been a bit downstream of where we are today, we think.
Did you catch that? The ancestral salmon Clearwater River contributed zircons to the conglomerate beds near Granger, a small town near Sunnyside. This is the same conglomerate noted in 1960 which has tons of stained quartzites indicative of the Columbia River. In most reconstructions I've seen, the salmon Clearwater enters the Pasco Basin on the southern margin and flows out to the southeast, even as the Columbia River flows toward Sunnyside. But the zircons tell a different story, one of mixing river channels. And if the zircons could mix, maybe the agates could too. Speaking of which, we should probably discuss how zircons tell us where these ancient rivers were.
Zircons are a small crystal that are in many geologic units. So they're actually pretty, I'm not going to call them ubiquitous, but they're common minerals that we find in sandstones, we find them in plutons and so forth. And they're very robust, which is what makes them so useful in geology, because they remain in the geologic landscape for hundreds of millions of years. What we're using them for is dating uranium-lead ages, and it doesn't give us an age always of the strata that's being deposited. It gives us an age of the upstream contributing geology. And so if I take a sand from a river that is draining, for example, a 50 million year old pluton, then I'm going to see a 50 million year old spike in the zircon, the ages of those distributions. And so what we do is we take some sand and we use magnetic separation and density separation to specifically take the concentration of zircons out of there. We want to separate those first. And then they're mounted on a slide and they're analyzed using laser ablation inductively coupled mass spectrometer. That's what we use. There are various different ways of getting uranium-lead ages, different mass spectrometers, but the LAICPMS is the method that we've used a lot and that many other people do as well. And so what this is analyzing is the uranium-lead age in which that zircon was formed, which could be at the time that the river was depositing, if there was an eruption at that time, or it could be the old pluton that has been eroding in the upstream catchment area. After we get the range of ages, the result is called a detrital zircon age spectrum. It's basically a bunch of zircon ages, and we use those zircon ages to make inferences about what parts of the landscape must have been eroding and what geologic units must be eroding to make that sand further downstream. The parts of the Snake River that are important for contributing to the zircons that we find in the Ringold Formation specifically come from the upper part of the Snake River drainage, so eastern Snake River Plain and upstream from there, like into Idaho. And a lot of these zircons are the really old ones that have been recycled through the Idaho-Wyoming thrust belt and have been, again, in the geologic environments and being recycled for millions of years. We find them here and they're farther upstream. Where we don't find those zircons are in some of the sediments that were being deposited in Lake Idaho, located in the western Snake River Plain, at the same time that the Ringold was being deposited. So that led us to suggest that the upper Snake River drainage, what is now the upper Snake River drainage, did not flow from the eastern Snake River Plain into the western Snake River Plain, but rather took a different route to get to the Columbia Basin. And we suppose that it was going a northward route. We suggest that because there are some sandstone deposits and cobble deposits along the way into southwestern Montana that seem to have a fairly similar zircon signature to the Ringold. One are these gravels right on Monida Pass on Highway 15, which is the Continental Divide right between Montana and Idaho. And another location is just downstream of there in the Ruby Graben. There's these gravels called the 6 Mile Creek Formation. And they seem to have a similar signature to the Ringold. And so that's why we suggest it went to the north rather than to the south. The reason, I think, why those basins were not connected, why the Snake River did not go into the western Snake River Plain until after 5 or 3 million years ago, was because the Yellowstone hotspot was located within that region prior to its current location in Yellowstone National Park. And so the Yellowstone hotspot is this really hot thermal plume that is adding quite a bit of buoyancy to the base of the crust, and through thermal expansion can cause topography. And so our hypothesis is that the river did not take its current course through what is now the full Snake River Plain because there was a topographic impediment caused by uplift along the Yellowstone hotspot 5 million years ago and before that too.
I kept coming back to Jason's comment about the hard line at Connell. That line matches up well with the easternmost margin of the main Ringold Formation. Perhaps the agates stayed in the combined Columbia-Snake River channel until reaching the lower energy environment of the Pasco Basin. But the agates we find at Fur Road are in a high-energy depositional environment, and if they came via a northeast Washington route, we should find them all the way upstream as well. So maybe instead, that line at Connell is actually the margin of the ancestral salmon Clearwater River flowing into the Pasco Basin. And in fact, in the past, that was the case. The salmon Clearwater was pushed north by the Umatilla member of the Columbia River flood basalts. That channel was later filled by subsequent flood basalts, and the river shifted back closer to its current route. Maybe part of that old river channel was reoccupied during Ringold time. If we stick with the theory that the agates were brought into the Columbia Basin proper via the salmon Clearwater, we can try tracking them upstream to identify the source. The Snake River took over the salmon Clearwater about 3 million years ago, after it carved a path through Hell's Canyon. Before that, during the Ringold time when the conglomerates like at Fur Road were being deposited, the salmon Clearwater pulled material from the Bitterroot Mountains, the Salmon River Mountains, and the Sawtooth Range, basically central Idaho. Jason has found a lot of similarities between CBAs and southern Idaho agates he digs up.
There's a ton of Bonneville material down in the valley. So imagine with the size and volume of those floods, there had to have been some splash over up onto the Palouse. And then here comes the Missoula floods, right? So that's one plausible explanation of all those agates, that they came from the huge agate fields in southern Oregon and Idaho, wherever that Bonneville pathway came from. It undoubtedly came through agate fields. Southern Idaho and that area, it's all old volcanics and it's just silicated. All the hills are silicated. So, and the agates match. I've hunted there. I have claims, agate claims in southern Idaho, in the high mountain deserts where the origin of a lot of agates that people find in rivers is. So I just kept going. I just kept going until I got all the way up into the mountains, into like high mountain desert. And there's tons and tons of material in these places. It's no secret, you know, like Arco and Sucker Creek, you know, all these places down in southern Idaho and Oregon in that area. It's very well known. You know, you can find them in place. And so it's very plausible that the Bonneville moved a ton of material, and then maybe some of it was swept up. Also, another theory is the Snake and Salmon rivers themselves. The headwaters of those rivers are also loaded with source material. So even if there were ancient river systems in place, the first third of those flood events would just completely wipe them down to the rock, you know, and then those agates would be deposited wherever the slosh was as the Missoula floods went through. There is a ton of similarity between the southern Idaho source material, which varies greatly, but there's a ton of similarity between the source material that you see down there and what these agates look like, except for the stain. This one was in the soil for about 10,000 years, but other than that, they're pretty much the same. And if you look behind you, I fill barrels full of those agates. Look at that one. Yep, that is exactly the same as the CBA I'm holding. Look at this. You won't believe it.
Yeah, without the staining, that would be...
And look at the color. I could go on and on and on. I have so many. So we've got pretty good examples of some that I've polished and or cut. Here's an incredible green and red and even leaning a little bit bluish or pinkish or purplish. That's a moss agate with some actual banding, right? Like this moss agate actually has some windows in it. So it's technically an agate. Here's a crazy one with tubes in it, and these tubes are kind of pink with a red center. And the agate itself is sort of an olive color. Very cool stone. This is an amazing stone. I face polished that. Look how plain it was from the other side.
No, I would have said, like, you cut that from that.
Mm-hmm. Yep. You're picking up what I'm laying down. Yeah.
Here I focused on the Ringold Formation, but not all gravel beds are that old. The Missoula floods obviously moved material around, but I haven't talked about the Bonneville floods adding material to the Columbia Basin. Despite the huge volume of water flowing from Lake Bonneville, the floodwaters stayed relatively confined to the Snake River Channel. But it wouldn't come as a surprise to find some material escaped the confines of the Snake, especially when looking at the evidence for the power of these floods in the gravels at Lewiston. There are some gaps to the story, like whether or not the southern Idaho agates Jason finds somehow made their way to the Columbia Basin during the Ringold. Or maybe that's looking at it too narrowly. Why couldn't there be multiple sources of agates? After all, there's a huge variety to be found, and perhaps even more yet undiscovered.
All of this is theory. Some of it's been measured and to some degree validated or had it follow a logic stream that makes sense, and so we all generally accept it. But if anyone tells you they know the answer, they're probably, well, they are mistaken, because none of us know for sure. So what we're doing is looking at all the evidence. Some of us have more, some of us have less evidence, depending on how much experience we have. And the theories sort of change depending on how much evidence a person has gathered.
What we're trying to work on now is analyzing more specific locations within the Columbia Basin to suss out the details and also suss out the timing a little bit more. So not just looking in the Columbia Basin at its margins, but in the center and then further downstream as well, to find more clues about which rivers came in when and when those changes really happened. Because it does seem to be a dynamic situation. There's a lot of drivers of topography acting upon this landscape over that time period, and they all have the ability to contribute to changing river systems. We think we've nailed down what the Yellowstone hotspot has done to the general history of this particular region, but there might be some more local interesting things as well that we find along the way.
There's some gaps in the information. Things don't quite line up perfectly, and that's okay. It's kind of fun that it's a mystery, but I think we're narrowing in on it. It doesn't seem that plausible that anything else would have happened, and it seems very plausible and likely that those agates could have been in the path and or in the Snake, even if they were in the presumably the Snake would have dumped into the Columbia back then, but I'm not sure. It's just a receptacle for every watershed above it. So if the ancient salmon had agates, which it would have, then the ancient Snake would have had agates, even if they weren't Snake River agates, and then the Columbia would have had agates, right? So it follows logic. This brown-white combo is not that common, and this is just such a rich example, and it's actually gotten better with time. I've noticed a lot with the CBAs after you get them out and get them cleaned up, as UV and other lights are exposed to them, they actually get richer in color, and a lot of the windows actually come into focus. Whereas a lot of other agate types, the more they're exposed to UV and stuff, the less colored they get and the more they kind of bleed out. So I find it interesting. A stone like this one, this was all, I remember when I found this stone, it was all one shade of brown when I found it. And these nice bright yellow bands were present, but it was, I even have photos of it. This frog skin, greenish brown contrast that came in, it all happened after I had collected this stone. This was a light, clear cream before I cooked it. I baked it at 350 degrees for about a half an hour. And this white came out once it cooled and got completely cooled. And I picked up that tip. Apparently they do it with Lake Superior agates sometimes to bring out, and in certain ones it'll bring out some contrast. Here's a couple examples of some amethyst, and these are nice and dark purple ones. I saw an example of one that had been found at Fur Road maybe a year and a half ago that was probably about this big, and it had a black purple center and a big quartz window, and it's one of the few I've seen that went so far as to be almost black. Earth tones and even crossing into the yellows and oranges a little bit. This is another one of those ones with the pink and red banding in it. I've heard people call these rainbow. This is a perfect example of a really complex stone. I mean, you've got unbelievable water washed fortification window right there, and you roll it up, tubes everywhere across the whole surface. We go over to the other side, you've got cross-sectioning of the tubes. Now you've got a quartz window with floaters, orbicular patterns because of the tubes, and water line in the bottom. Pretty awesome. Pretty awesome stones.
I've spent a lot of time here discussing the origin of CBAs, but at the end of the day, it doesn't really matter. Even if they formed in Idaho, I don't think anyone is going to try to sell you a fresh Idaho agate as a Columbia Basin agate. They're both still pretty and interesting in their own right, but they're not the same thing. The most unique aspect of Columbia Basin agates to me is the stained exteriors. CBAs need that time in the rivers and iron-rich environments to really come into their own. And what's really important is that we enjoy the hunt for these elusive agates.
I have not found any beautiful agates. Even though I typically work on the sand fraction of stuff, I have been paying quite a lot of attention to the gravels as well, because they're not only interesting scientifically but beautiful. But I am systematically terrible at finding things like agates in the landscape. So otherwise I would tell you where I found them.
So, CBAs, I know you're out there. I'm coming for you someday.
I am so excited you thought of this. I can't believe of all the people I've learned from and talked to and done all this, I cannot believe this very obvious concept has not crossed any of our minds yet. This is definitely worthwhile in terms of, I would have no problems giving you what you need to do that. So I'll just leave it at that.